Hello everyone, once again welcome back to my YouTube channel, the SCADA Insider. So today we are diving into the communication protocol that is Modbus, which is one of the widely used protocols in industrial automation. And first I will explain you regarding the protocol, and then we will demonstrate how to communicate WinCC OA SCADA with this particular Modbus simulator. Okay. So what is Modbus? It is basically a communication protocol. It was developed by a company called as Modicon, and it was developed in 1979. It is used for communication between devices like PLCs, sensors, meters, SCADA systems, and all. And we can say it is a protocol where we like can say it is a request and response protocol where SCADA system act as a master. It requests data from the slave. In this case, slave device may be the PLC, it may be any kind of meters, sensors, any other devices. So SCADA as a master, and the other device which will be sending data as act as a slave device. Now in Modbus, we have around two type of configurations available. First one is Modbus RTU, and second one is Modbus TCP IP. So what is Modbus RTU? Is basically it is a serial-based communication protocol where we use RS-232, RS-485 serial cables to loop all the devices in a pair, like we do a looping of all the devices, and then the final loop goes to a converter, and via converter we fetch the data into our system. And on the other hand, Modbus TCP IP is taken over Ethernet communication, where we have dedicated IP addresses to all the devices which are communicated in the network. Okay. Now the third part, which is coming into the Modbus, is we have different memory addresses for different kind of register types and function codes. Like we have register type like coil, discrete input registers, holding register, along with their function codes. Okay. Now we will do the configuration, so you will get a clear idea how we do this kind of communication for Modbus in the WinCC system. So in my previous tutorials, I've shown you how to create a demo project in WinCC. We will use the same project to communicate this simulator with WinCC SCADA. In this case, we are using Triangle Microverse test harness, where we can create a simulator for Modbus. So how to create a simulator? I will just go to this particular open channel. I will select a protocol as Modbus, and server has, in this case, our this particular Modbus simulator will act as a SCADA server, and our SCADA will act as a Modbus client. Okay. In here we will set a unit identifier as 1, and in host IP I will just mention it as a 127.0.1, that is local IP. Uh, in the real-time scenario, each device will have its own IP which is need to be configured in SCADA. Now we have configured the device and we get a data window here. So as I earlier mentioned that we have different kind of register types available. So here it is coil, then discrete input registers, holding registers. Okay, so the changes which we make in the values will be reflected in the SCADA system. Now starting the SCADA project, I will just go to the demo project and start the project. So one by one, all the managers will be started. Now in the Modbus case, we need to add a driver, that is Modbus driver. Here we can see how to append this driver. Again, go to the append new manager. Here we are having all kind of drivers available with us. In this, select the Modbus driver and just take care that the number of that driver should be unique. So in IEC 104, I've used the driver number as 1. In DNP, I've used as 2. So Modbus, I will be giving the driver number as 3. It should not, so that it will not conflict, will not give any error on the Modbus driver. Okay, we will go to the development environment. Now in development environment, first what we need to do is basically we need to create a Modbus device which will communicate with this simulator. So for communicating with this simulator, we will create the device under this system management. In system management, we go to the driver, and driver we go to the Modbus driver, and here we will get a such kind of window available in front of us. Here we will create one device. It will ask whether you want to give what kind of PLC number. I will just state as 1. So this is my first PLC device which we need to communicate with our SCADA. Now, the thing which need to be taken care is like in test harness, the particular server which we have created, we just need to check what is my unit identifier? So here the unit identifier is 1 and the host IP is this one, port number is 502, which is default for Modbus. Same need to be configured in this SCADA device list. Okay, here. So you maintain unit address as 1, then 127.0.0.1. Here they have asked host name and port number 502. Now many times what user do, they just mention this particular IP here, they don't open and they click on apply button. In that case, the list, this IP will not be available in this list and the device will not communicate. So ensure that we add this particular host into this list. Okay, make the common settings here active so that the device will be active to communicate with this simulator. Now click on apply button. On clicking apply button, we can still see that the device state is not connected because until and unless we create any kind of data point in our para, this will not go into the connected state. So for now, we will just go to para. And for my previous tutorial, I've used the same particular data point type, that is circuit breaker, and we will create a new data point inside this data point type. I will create 3B3. Okay, so this is my new device, CB3. In this CB3, we have different kind of data point elements available. One of Boolean type, one of float type, one of integer type. Okay, first we will communicate, like we will make the addressing for this Boolean address. Now for adding address, as I also shown in my previous tutorial, we click on this, right click on this tag, and then we insert config periphery address. Once we insert periphery address, here when we click on this address, you will see this kind of configuration. In this configuration, we need to select the Modbus driver and click on configure. So once you click on configure, you will get this configuration window in front of you. Now in this case, we are fetching data from the simulator, not sending data. So our direction will be the input direction. And in this case, we will be polling data from this simulator. So we will maintain the receive mode as polling. Poll rate will be 1 second. And the data point type, data point element type is like, we can say it is a Boolean. So I will select the transformation as Boolean. Again, the PLC number, it is asking me PLC number. So the PLC number can be fetch from here. So PLC number which we have configured is 1. I will make it as 1. Okay. And make the address active and click on apply button. So here we can see uh, the device is still not communicated. Why so? Because we have maintained the driver number as 3. Same need to be configured here, driver number as 3, and click on apply button. As soon as this configuration is proper, we can see immediately the state has been changed to connected state from not connected. Now this particular tag is being communicated with this simulator. Okay, we can see the actual timestamp which is being pulled by this SCADA from this simulator. If I go to the coil and the address which we have configured is 0, if I make changes in this address 0 in this simulator, will will make the value as 1. See, immediately the value is reflected here. The value is being getting changed. I will just change the value to false. Okay, false. Now if I change the reference number to 1, click on apply. It's original. For reference number 1, the value is continuously 1. I will make it to 0. Then the value is becoming false. So this was configuration for the Boolean values. Now we will just have a demo for an integer value. Again, I will go to this V1, insert config, then periphery address, add the Modbus configuration here, configure, and again the input direction. Okay. So in this input direction, we will select as read multiple registers because we are having a integer value which will be taken from this system. Then type as int16, polling, poll group we will maintain as 1, driver number 3, PLC we will take it as a 1. And suppose in this case read holding register, if I take the address as 1, we will just make it as 1, make address active, apply. As soon as we apply, we can see the value which is available in address 1 is reflected it here, right? If I change the value to any other value, like I will make it as 50, immediately our value is being change to 50, right? So in this way, we can communicate the Modbus devices with the SCADA system in WinCC UA. We'll make the value change to 20, and yeah, the value is getting changed. Similarly, if I change insert config periphery address, we'll just give a try. If I make it as a boolean, one right coil, reference number one, driver three, address active, apply coil. And if I make it as one, no, it's for the simulator, this command is not working. But in the same way, what we can do is if you want to write any address, so you just click on direction as output, then you need to give the device name here, a reference number, and you mention this as a right coil. Okay. So in this case, the particular address will be we will give the command to that particular address in the PLC. So this was a short demonstration for Modbus communication with WinCC and a simulator device. In the similar pattern, you can do the communication between all the devices which are supporting the Modbus protocol. Okay. So in next tutorial, we will see the communication between DNP3 and DNP3 simulator and WinCC SCADA. So stay tuned for the next tutorial. Have a nice day. See you.